Hello everyone, let us solve this simple problem. Solution: we have 3 to the power of 2x minus 8 into bracket 3 to the power x minus 2 then minus 73 equal to 0. Again, I want us to rearrange this. 3 to the power of 2x can be written as 3 to the power x all squared, because if you want to open this bracket, you will still multiply the powers to have 2x, then minus 8 into bracket 3 to the power x multiplied by 3 to the power of negative 2, then minus 73 equal to 0. So that from here, I can now take another step to say 3 to the power of x raised to the power of 2 minus 8 into bracket 3 to the power of x multiplied by 3 to the power of negative 2 is the same thing as 1 over 9. Close the bracket. I'll have minus 73 equal to 0. From here, I will take another step to have something like this: 3 to the power of x squared minus 8 into bracket 3 to the power of x, then everything is over 9 minus 73 is equal to 0. So from here, I can multiply everything by 9 because it is the LCM. So 9 times this will give me 9 multiplied by 3 to the power x all squared, minus 9 will cancel itself from here, and I'll have 8 into bracket 3 to the power of x, then minus 9 multiplied by 73, and that 9 multiplied by 73 will give me 657. So I have 657. This is equal to 0. From here, I now have a quadratic equation. Let 3 to the power of x be equal to y. So meaning that here, I will have 9y squared minus, from here, we have 8y, then minus 657 equal to 0. Okay, so that's from here I can now solve this using factorization method, but because I have 9 here as the coefficient of y squared, I'll have to multiply 9 by 657, and that will give me, let me write it here, that will give me 5913. So I'll have 5913. So the next question will be, what two numbers do you multiply to have 5913, and that you will add the two of them to have minus 8? The two numbers will be it will be 81 and 73, because, okay, let me take another step. Here I'll have 9y squared, then minus 73y, okay, it should be plus 73y minus 81y, then minus 657 is equal to 0. This is because plus 73y minus 81y will give us minus 8y. Then 73 multiplied by minus 81 will give us minus 59.5913. That is 5913. So this means that this is now a balanced equation. So I will group this way and factorize, and group this and factorize. So what is common to these two is actually y. So if y comes out, in here I'll have 9y, then plus, if y comes out of here, I'll have 73, then I'll close the bracket. 81y minus minus 81y minus 65 7. We don't have 81 common to both of them, so I'll just pick minus 9 as the factor, because 9 can go into 81 to give us 9, and then the y will still appear. Because of this negative, we're going to have positive here. Then 9 into 657 will give me 73, and everything is equal to 0. From here, we now have the same thing in the bracket, so I can say that y minus 9 or 9y plus 73 is equal to 0, meaning that either of these two or both of them are equal to 0. So I can say that y minus 9 is equal to 0, or 9y plus 73 is equal to 0. And from here, I will say that y is equal to 9, or on this side, 9y will be equal to negative 73. Okay, so y is equal to 9, or on this side, y is equal to minus 73 over 9. But here we're having negative value of y, so we're not going to deal with the negative value. Let us deal with the positive value of y, which is y equal to 9. But remember that at some point we said let y be equal to 3 to power x. So in place of y now, I'll have 3 to power x, and then this is equal to 9. And then I can take another step to say that 3 to power x is equal to 3 to power of 2, because 9 is 3 to power 2. So that's from here, the bridges are the same, and I will work with the powers, meaning that x is actually equal to 2. So this value satisfies the equation given there. This particular equation will be correct if you substitute x as 2. Thank you for watching.